In this chapter, we will be covering substance-related and addictive disorders, with most of the focus on various substances that can be addictive. Besides talking about the various substances in turn and their addictive properties, we will also talk about contributing factors and treatment approaches. Our final topic is an addiction-related disorder called gambling disorder. When we talk about substance-related disorders, which previously we would refer to as addiction, we are talking about the use and the abuse of psychoactive substances, despite the fact that there's considerable cost and significant impairment. In most cases, people who abuse substances actually abuse several different substances. We'll also talk briefly about impulse control disorders near the end of the chapter as well. Before we begin, let's talk about levels of involvement with drugs. If you smoke a single marijuana cigarette, that's substance use. You may not be addicted, but it's substance use. If you smoke enough that you are not able to function at a reasonable level, that's intoxication. In the next slide, we'll talk about the distinction between abuse and dependence. Many people confuse the terms abuse and dependence when we're talking about drugs. With abuse, we're talking about recurrent use, despite the fact that it's created legal problems and difficulties in your life, and to the extent that it is preventing you from fulfilling your major roles. Dependence is talking about an addiction process, and dependence includes two physical concepts: tolerance, the need for higher doses to get the same effect, and withdrawal, an adaptation of the body such that the body doesn't function well without the drug, and often experiences dramatically uncomfortable situation when the drug is stopped. In theory, almost every drug could be addictive, but very few drugs are highly addictive. This table from Health Magazine gives you an idea of how addictive certain drugs are. You may be surprised to see that nicotine in cigarettes is the most addictive drug, as addictive as methamphetamines or crack or crystal meth. Some of the drugs that you think of as very addictive, such as heroin and cocaine, are not nearly as addictive as you might have imagined. And caffeine is as addictive as heroin or cocaine. There's a lot of debate about what we mean by substance dependence. Many people have suggested that it is a disease model and that it should be treated as a disease rather than as a character flaw. The relapse rates are clearly very high, which means that even if you are successfully treated, the odds are very good that you will begin using the drug again. There are a number of mechanisms of addiction. We will talk about those later on. Most of those will focus on individual drugs. In general, people who abuse drugs tend to abuse many drugs and often become dependent on several of the drugs. We don't use the disease model as much as we once did. It implies that you can catch the disease in some ways. But we use the disease model in the sense that we know that not everyone is equally likely to develop the disorder, that one's genes has an impact, but also the environment in which one is raised can have an impact as well. I mentioned relapse, which is essentially after successful treatment, one starts to use the drug again. Relapse occurs very frequently. This curve, for example, shows the relapse rate over 1 year from the time of successful treatment for heroin, tobacco, and alcohol. And what you might notice is that alcohol has the lowest relapse rate over 1 year. Tobacco and heroin have an equal relapse rate over 1 year. It's hard to quit smoking. Now, it's not strictly psychological. There are clearly biological components. Genes play a role, but the role is different for different drugs. And for many drugs, we don't know exactly what the role is because we have almost no one who abuses only that drug. We do know, for example, that alcohol dependence runs in families, but as you're going to learn, that's a very complicated relationship and with a few surprises. We know that there are neurological factors involved, and some of them we have a pretty good idea from animal models. Neurons adapt to the environment that they're in. And when we change that environment through using drugs, the neurons adapt to those drugs. And their neural circuitry itself can be affected, which changes the way we feel, the way we think, and the way we behave. Tolerance and withdrawal and the cravings that can go on sometimes for years after we've no longer used the drugs are all biological. It's not just biological, though. There are a lot of psychosocial components. Culture makes a huge difference. Various ethnic groups and social groups either are more or less likely than other groups to abuse certain drugs. Drugs also affect the way we feel. In some cases, in positive ways. They make us feel more energetic or feel enjoyment, and that tends to reinforce the use of the drugs. But drugs also change us, and as a result, when we're not taking the drugs, we can be extremely uncomfortable. And that's a negative reinforcement. We are then taking the drugs to feel less uncomfortable. Finally, we're going to talk about expectancy effects. Some of the issues that we will deal with in this chapter are less a function of the drug and more a function of what we expect the drug will do for us. The first class of drugs that we're going to talk about are called depressants. They're called that because they are central nervous system depressants. They inhibit the nervous system. And in fact, they can inhibit the nervous system to the extent that the nervous system stops functioning and we can easily die. They do that by affecting a variety of systems, starting with the inhibitory centers, which is one reason why these drugs often make us feel more relaxed and comfortable. Primarily, they involve three neurotransmitters: GABA, which is an inhibitory neurotransmitter, glutamate, and serotonin. We're going to start with alcohol, which is the most commonly used central nervous system depressant. We make alcohol by fermenting grains and fruits, and alcohol is a byproduct of that fermentation process. What that does is it preserves the calories, not the nutrients, but the calories, and it preserves it in a form that will not spoil. In fact, alcohol prevents the germs that cause spoilage. That's why, for example, if you get a shot, they use an alcohol swab to rub the skin. It kills the germs so that when you penetrate the skin with the needle, that you are very unlikely to introduce germs under your skin and therefore into your body. Alcohol is used quite frequently in many cultures. Roughly 2 billion people on this planet use alcohol, many of them socially. Relatively small number to abusive levels. Now, 2 billion certainly sounds like a lot, but there are over 7 billion people on this planet which means a relatively small number of the total people on the planet use alcohol. Everyone knows what it's like to be drunk, even if you yourself have never experienced it. That's called alcohol intoxication. And you can predict intoxication with a high degree of accuracy. It's based on your body weight, and to a lesser extent, whether you're male or female, and the contents of food in your stomach. Food will bind with the alcohol for a short period of time before the alcohol then is broken down separately and enters your bloodstream. Females can, for the same body weight, experience more intoxication than males. Now, why is the body weight important? The body weight is almost directly proportional to the volume of blood. And as you're going to learn later, the level of intoxication can be monitored by looking at the blood alcohol level, or BAL. So if you weigh more, you'll have more blood. Therefore, it takes more alcohol to get a high blood alcohol level. Now, your body breaks down alcohol, and it does it at a constant rate, regardless of your weight. You break down roughly 1 drink per hour. Now, the drink has to be a given size. So if you're drinking a beer, we're talking 12 ounces. If you're drinking wine, we're talking a small wine glass of roughly 4 ounces. And if you're drinking a mixed drink with spirits, we're talking about 1 ounce. If you actually look up the alcohol content for beer and wine and 90 proof spirits, which is 45% alcohol, you'll see that it is the same amount of alcohol in each of those drinks. You break it down at roughly 1 drink an hour, so if you are drinking 1 beer an hour, you will never become intoxicated. But if you exceed that amount by 3 drinks at any time during the night, so for example, if you drink 5 beers in 2 hours and you weigh 150 pounds, you're going to be legally drunk, which is an alcohol level of 0.08. Now, if you have no alcohol in your blood, of course, your blood alcohol level is 0. And if you have 1/2 of 1%, you're going to be dead. That's a lethal amount. Fortunately, it's hard to get that level of alcohol in your blood because you'll probably pass out or be so incoherent that you can't remember to keep drinking. But this graph here shows typically what it is that you will experience at each level, and these are remarkably accurate predictions. So at 0.08, you are legally intoxicated in all 50 states, and you're likely to lose your license for a considerable length of time. You should not be driving. You're dangerous, not only to yourself, but to everyone else out there. By the time you reach double that level, you have serious problems that are affecting more than just your driving. Serious coordination problems. You could easily trip and fall down some stairs, for example. Your judgment is terrible. Your mood fluctuations can be all over the place, and you can't think clearly. By the time you reach 3 times that level, you are talking about not being able to speak. Your voice is horribly slurred because you can't pronounce words. You're likely to experience the room spinning. That's due to an eye movement called nystagmus. In nystagmus, your eye moves very slowly in one direction, and then when it gets to the end, it snaps back. And it moves very slowly and snaps back. You can't feel your eye doing that, so you experience the room as if it's moving in the opposite direction that your eye is moving. Now, you've had this experience. If you're in a car, you might be looking down and suddenly you slam on the brake because you think that you're moving. In fact, you're not moving at all. It's the car next to you that's moving, that gives you the impression that you are moving. Also at that level, you may experience alcoholic blackouts. Now, you might think that means passing out. Now, in an alcoholic blackout, what is happening is you can no longer record memories. And it would be better if you were passed out, because you have such poor judgment, you're likely to do and say some outrageous things. And the next day you won't have any idea because they've never been recorded, at least not in your brain. We can measure the blood alcohol level two ways. We can take a sample of the blood and measure it that way, but we don't need to. Because alcohol passes through the lungs just as easily as oxygen and CO2, the level of alcohol in the blood is the same as the level of alcohol in your breath. So we can use a breathalyzer. No matter how drunk you get, you won't be dependent, at least not immediately. Alcohol dependence takes quite a while to develop, and as it develops, you will need more and more alcohol. So perhaps initially you start with beer, and maybe a couple of beers relaxes you, and then later you need 3 or 4. That's a build-up in tolerance. Many people who become dependent on alcohol will switch from beer to hard alcohol because they can't consume enough volume of the beer to get the effect that they want. They would have to drink a whole case in an evening. So they drink vodka because it takes much less volume. Once you stop drinking, after you become physically dependent, you go through what are called the DTs, or delirium tremens. You don't ever want to do that. You don't ever want to even watch someone go through that. They are horrible. You feel like bugs are crawling all over you. You feel like you want to scratch your skin off. You can die because the DTs can be so intense. And they don't last an hour or two. They can last for days. What's the effect of long-term alcohol use? Well, you're probably all aware that it damages your liver. In fact, most people whose liver has become cirrhotic, that is, having cirrhosis, which is a hardening of the liver to the point that it doesn't function, their liver's that way because of heavy drinking over a long period of time. But it isn't just your liver, your heart. Cancers of all type are related to alcohol consumption. Diabetes can be triggered by alcohol consumption because alcohol, as it breaks down in your system, turns to several products, including sugars. There's severe inflammation of the stomach in heavy drinkers because, well, alcohol is rather toxic to your stomach. And think about that. Stomach acid is one of the most powerful acids available on this planet. It can break down just about everything. The fact that alcohol can make an environment even more toxic than stomach acid is pretty impressive. Also, it kills brain cells. Now, your brain cells are dying right now, and they've been dying since you were about 3 months old, and they will continue to die until, well, you die. They die at a fairly steady rate, but when you are intoxicated, they die at a much higher rate during that intoxication. Now, if you go out tonight and you just get drunk as hell, you'll have a hangover tomorrow, but your IQ won't be lower. Because the way our brain is wired, we can tolerate a lot of dead neurons. Remember, neurons don't grow back, not like other cells in our body. And that's good because, well, our neurons are dying all the time. We don't want our brain to effectively be useless by the time we're 20. But it builds up over time. So if your neurons are dying at a much higher rate because you are consistently drinking a lot and increasing the rate of cell death, you won't notice it the next day. You won't notice it the next year. But by the time you reach retirement age, it will be noticeable. Now, most people who are addicted to alcohol do not reach retirement age. They die of cirrhosis or heart disease or diabetes and the complications of it. That is, the alcohol takes such a toll on their body that they just simply age much faster. But if by chance they make it to retirement age, their brain is going to look more like someone who's 85 or 90. They're going to show signs of dementia. They're going to show significant cognitive decline, not the result of one bender, but the result of constant intoxication over many years. And it's not just the neurons in the brain. It's also the neurons in the periphery, which means that if you're a chronic alcoholic, the neurons on the bottom of your feet, which are exquisitely sensitive, you can close your eyes and stand up just fine because every slight movement, your feet's going to pick it up and your body's going to respond to keep your center of gravity over your feet. But if you're a chronic alcoholic, those neurons aren't going to work very well. You're going to close your eyes and in about 30 seconds, you're going to fall over, literally fall over. Okay, so chronic drinking over a long period of time takes a terrible toll on your body and your brain. In the short term, we're familiar with intoxication effects. What you may not know is that the intoxication effects are so predictable that if a police officer pulls you over and doesn't have a functioning breathalyzer, they can do a field sobriety test. And on the basis of what you can and cannot do, they will know exactly what your blood alcohol level is. And by the way, in court, that holds up every bit as well as a breathalyzer test. We've talked about some of the things that are associated with it, like slurred speech and blackouts that occur, but there's also motor movements that are affected. For example, it's relatively easy to touch our nose. Even when we close our eyes, we can still touch our nose. But if we are slightly intoxicated, meaning 0.05 to 0.08, this is what happens. We miss our nose. We miss it sometimes by several inches, and we miss it repeatedly. There's also short-term effects that we're talking about the next day, and that's hangovers, and we'll talk about that later. And then expectancy effects, which are very important, and we're going to focus on that because, well, it's not only important to alcohol, but it's important to all drug effects. When you take in a drink, the alcohol goes into your stomach. It's absorbed mostly in your intestines. Happens relatively quickly, and you know the effects. Initially, you feel more relaxed, less anxious. Eventually, you'll start showing the motor problems that are picked up by a field sobriety test and other signs of intoxication, including some pretty severe signs of intoxication. But it isn't just the alcohol that's doing it. What's also doing it is what we call an expectancy effect. When you take a drink, you have an expectation of what that drink is going to do. And that expectation often affects the way you feel. Now, one quick example of it, it takes several minutes for the alcohol to get to your bloodstream and make you feel more relaxed. But often people will take a drink and then a deep breath and say, oh, that felt good, I needed that. The only effect they were experiencing at that point is expectancy. The alcohol isn't in their system yet. By the way, people do the same thing taking a cup of coffee in the morning. You're barely walking and take a cup of coffee and they're like instantly awake. That's mostly an expectancy effect because the caffeine isn't going to be having much of an impact on you for another 10 or 15 minutes. The problem is when we take a drink, we're doing both. We're having a physiological effect due to the alcohol and at the same time a psychological effect due to expectancy. By the way, there's a special name for expectancies under certain circumstances. If you take a sugar pill and you're told that it's a powerful pain reliever, you will experience less pain. And your physiological arousal normally associated with pain will be affected. Your body's actually changing. We call that a placebo effect. An expectancy is just one type, a placebo effect is just one type of an expectancy effect. So how do we separate the two? What we do is create a situation where the two happen independent of one another. Normally we drink and we have expectancy, but if we drink alcohol and we don't know we're drinking alcohol, if we think we're not drinking alcohol, we'll have an expectancy effect in one direction, a physiological effect due to the alcohol in the opposite direction. So we create what is shown here in the graph, a 2x2 design, where people are either drinking alcohol or not, and they are told that they are either drinking it or not, which means half the times what they're told is correct. They're drinking alcohol and they're told they're drinking alcohol. And half the time they're not drinking alcohol and they're told they're not. But we also have a group that is not drinking alcohol but thinking they are. And a group that is drinking alcohol but thinking it is not. If it's the alcohol that makes a difference in how you behave or what you feel, then it doesn't matter what you think you're doing. It only matters what you're actually doing, which means drinking alcohol will have the effect. And in the graph we have here, the table, there are two cells, 1 and 3, where you're drinking alcohol. In one, you know you're drinking alcohol, and the other, you think you're not, but in both cases, you are. If it's the expectancy effect, then it doesn't matter whether you're drinking alcohol. It only matters whether you think you are. And those are cells 1 and 2. So that's how we separate out these effects. Now, what's very clever is how good they are at deceiving people. And they've developed some wonderful techniques to make people believe they're drinking alcohol when they're not. For example, they'll mix the drink in front of you. Okay? But it could be that the alcohol in your vodka bottle is not really vodka. But the vodka bottle is brand new. Has a tax stamp on it, just like you got it from the liquor store. The seal is broken, the tax stamp is broken. But what the people don't know is that you have a machine in the back room that will take any bottle and reseal it. That you can buy these tax stamps from any state. They're happy to sell them to you. Stamp collectors buy them all the time. And you can put it on there so it looks like it's a brand new bottle. But it's actually distilled water. You make sure you use something like vodka because it has very little taste. And you add something that even hides that taste, like orange juice, which is called a screwdriver, orange juice and vodka. Many people who don't like the taste of alcohol will drink screwdrivers because it doesn't feel like you're drinking alcohol, or at least it doesn't taste like it. So you can fool people. And by the way, when you give them orange juice that actually already has the alcohol in it, you do that from a brand new bottle of orange juice right out of the store. Except what you really did is you got it from the store, you opened it up, you put in enough alcohol to have the effect, and then you took another machine in the back room and sealed it up so it looked exactly like it looks when you bring it home from the store. At any rate, over 99% of people are easily fooled by this, and the results are fast. Before I talk about hangovers, let me just tell you a little bit about the results of the design we just talked about, which is called the balanced placebo design. Generally speaking, all the physiological effects, slower reaction time is due to alcohol, has virtually nothing to do with expectation. And all the psychological effects, feeling more relaxed, feeling more outgoing, etc., has to do with expectations. The one psychological effect is aggressiveness that is more of a function, not of the expectancy effects, but the actual level of alcohol. Now, one topic that many students are interested in is hangovers. No one likes a hangover, and they want to know how to avoid hangovers and how to cure them once you get it. So, there's a very simple way to avoid hangovers. Don't drink too much. You get a hangover for two reasons. One is the dehydrating effect of alcohol. You probably noticed, if you drink, that you often go to the bathroom a lot more when you drink, because alcohol is a diuretic. It moves more of the liquid that's in your body into your bladder to be expelled in the toilet. So if you drink a lot of water while you're drinking, that will decrease the effect. If you wake up with a hangover and you have a cotton mouth, it's extremely dry, that's because of the dehydrating effect. But there's another effect. This is harder to deal with. When you ferment anything, part of that process creates alcohol, but part of it also creates what are called cogeners. Those are the byproducts of fermentation. They often give alcohol its unique taste. So depending on what it is that you are fermenting, grains, potatoes, fruits, there will be distinctive tastes that are part of the cogeners. Cogeners also give color to alcohol, which will tell you, for example, that a alcohol like vodka, which has less taste and less color, will have fewer cogeners. Now what happens is cogeners are treated by your body as invading organisms. They look like flu viruses and the body fights it off. So most of what a hangover is your body thinking it has the flu. So it does all of the things that are associated with the body response to fight off a flu. That's why you're nauseous. That's why you have body aches, headaches, diarrhea. All of that is your immune system thinking it's fighting off a health problem. I should also tell you that there are other complications. Some of them reversible, others not. For example, if you drink a lot, there's a lot of calories in alcohol. Remember, alcohol started out as a way of preserving calories. So you could ferment grains, which would last for months or even years, rather than try to store them and have them go bad. But they don't have much in the way of nutrients. So you get your calories, well, you're not very hungry, so you don't eat the foods that give you normal nutrients. And you can get vitamin deficiencies because you're just not eating enough of the good foods that you need. Korsakoff syndrome is a result of a vitamin deficiency. And you can actually undo it with vitamin pills or at least reduce it, but it's definitely a complication associated with heavy drinking. If you're a woman and you're pregnant and you drink, the alcohol affects your fetus, and it affects the brain development of your fetus. In fact, it affects all of the development of your fetus. So the fetus will often be born with serious mental retardation and hyperactivity and a variety of other psychological symptoms, as well as a variety of complications that are of physical nature because of the effects of the alcohol on the developing fetus.